Example 8. Calculating probabilities using Poisson formula and table. Okay, so let's read the question first. The number of telephone calls made to a switchboard daily has a Poisson distribution with a mean of 8 calls in every 5 minutes. Find the probability that in the next 5 minutes A, B, C, D, E. Okay, so we extract the information from the question. So it is given mean is 8 and the interval is 5 minutes. Means the interval is like 5 to 10, 10 to 15, 15 to 20 and so on. Note X as number of calls in 5 minutes and we identify the Poisson distribution. So the question says find the probability in the next 5 minutes and our X is also in 5 minutes. So we don't have any problem in this example. But if they say in the next 10 minutes, then our mean would have to change as well. If 10 minutes, our mean would be 16. Next, we identify the probability of occurrences. So no call is made, X is 0 because it's a none. 5 calls is made, exactly 5, so equals 2. At least 3 calls is made, means 3 is a minimum and 3 is included. So more n equals to 3. And less than 4 calls is made, so 4 is a maximum and 4 is not included. Between 3 and 5 calls are made inclusive. Inclusive indicates that we should use the equals to sign. So we have 2 ways to find the answers, one using the formula and another using a table. Formula shouldn't be any problem, just substituting the values. As for using the table, we need a probability of all the other values other than 0. 0 is not included. So we use the total probability of 1 and subtract it with the rest, which is more n equals to 1. And we find the value from the table. So at the top we read the mean, which is 8, and at the R we read the number that we want. We want X is greater than 1, so we read the 1. Okay, as for question B, we use the same tactics as we used for the question A. More than 5, subtract with more than 6, so you get only X equals to 5, and you read from the table. So question A and B, the probability was equals to X equals to 0 and X equals to 5, so we can apply the formula directly. But for now, it's using the inequalities, more than sign. So it's still the same, but we use the total probability 1 and minus it with X equals to 0, 1 and 2. Because it's less than 3, so we get the probability of more than 3. But it's a longer process and requires us to waste few minutes in there, so we only use this method only if it's like requested by the question. Or not, we can just use the table and finish it off within few seconds. The same process again for question D. So for the formula part, the inequality does not include 4 and we need probabilities of less than 4, so we add 0, 1, 2 and 3, and using the table it's the same. 1 minus more than 4 to get more n equals to 4, so that we can get less than 4's probability. Okay, as for the question E, using the formula shouldn't be any problem since it's like between 3 and 5, so we only need 3, 4 and 5. We do the same for the formula, and for the table it requires a little bit of thinking, just a little bit. We subtract more than 3 with more than 6 so that we can get the probability in between. We only need 3, 4 and 5. So if you still find yourself struggling, you have to do more exercise.
About example 9, the number of breakdowns in a particular machine occur at a rate of 2.5 per month. So X is equals to number of breakdown per month. The mean is equals to 2.5. For question A, there is more than 3 breakdowns occur in a particular month. So for question B, there is less than 10 breakdowns occur in a 3 months period. So we denote the 3 months period with a Y, that is the number of breakdown in 3 months. For C, that is exactly, that means it equals to the probabilities is exactly equals to 3 breakdowns occur in the 2 months, so we denote the 2 months with Z. Z equals to the number of breakdown in 2 months. So for question A, the probabilities is using the same mean, that is the 2.5. So there is more than 3 breakdowns occur in a particular month. We use the greater or equals to 4 to make it qualify to read from the statistical table. We get the answer is 0.2424. For question B, there are less than 10 breakdowns occur in 3 months. So for the new time period, we need to find the new mean, which is the 2.5 times with 3, we get the 7.5. For this question, we need to find the probability of y that is less than 10. So that is equals to 1 minus probability of x greater or equals to 10. Read from the statistical table, 1 minus 0.2236, we get the answer is 0.7764. For question C, the number of breakdowns in 2 months is denoted with Z. So we find the new mean with the 2.5 times with 2, we get the 5 as the new mean. So we need to find the exactly 3 breakdown occurs in 2 months period. So the probability of Z equals to 3 is equals to probability of Z greater or equals to 3 minus probability of Z greater or equals to 4. So read the both of it using the statistical table. The final answer is 0.1403. Moving to the example 10, the cars arrive at the petrol station at an average rate of 30 per hour. So the mean is equals to 30. For the question A to E, we need to find the probability of different situation with different mean. So we use the different variable to represent the different interval for question A to E. Question A, we need to find the probability of no cars arrive during a particular 5 minutes interval. Firstly, we need to change the 30 per hour into the minutes. So 1 car is equals to 2 minutes. X is equals to the number of cars arrive in 5 minutes interval. So the mean is equals to 2.5. We use the Poisson formula to find the final answer for A. That is 0.0821. For question B, we need to find that the probability of more than 3 cars arrive during a 5 minutes interval. So in order to directly read from the statistical table, we need to find the probability of x greater or equals to 4. That is equals to 0.2424. For question C, we need to find the probability of more than 5 cars arrive in 15 minutes interval. That is, we represent it with the y. So 2 minutes is equals to 1 car, so 15 minutes is equals to 7.5 cars. Y is the number of cars arrive in 15 minutes interval, so the new mean is 7.5. So we need to directly read from the statistical table. Y is greater or equals to 6, so the final answer is 0.75x6. For question D, we need to find the probability in a period of half an hour for 10 cars arrive. Same like the previous question, we need to find the new mean, that is the 15. So we need to use the Poisson formula for this question. The final answer is 0.04x6. For question E, we need to find the probability less than 3 cars arrive during a 10 minutes interval, and we denote the situation with M. So we use the total probability 1 minus the probability of M greater or equals to 3, and we find the new mean for question E. Then we read from the statistical table 1 minus 0.x753. We get the final answer is 0.1247.